Okay, so here's another formula from the back of the book that looks kind of intimidating. But if you focus on what it's saying, if you wanted to integrate sine of x raised to the nth power, then you can sort of get it in terms of lower powers. And in fact, you can reduce it to something involved the n minus second power. So there's a name for this. This is called a reduction formula, because you could sort of keep applying this and reduce, even if you wanted to integrate like sine up to the 100th power, right? You could apply that, you'd have a computer apply this over and over again and actually get a formula, because eventually you get down to sine, eventually if you keep doing this, keep subtracting 2 from the exponent, you get down to sine to the first, which is just sine, or sine to the 0, which is just 1. So let me do an example just to show you. This is kind of like the weird e to the x sine x integral. Let's just do the 4th power of x. Let's not try to kill ourselves too much. Okay, so what you're going to do here, kind of like in the last video, where you're going to strip off a sine. And we're going to rewrite this as the integral of sine x times sine x cubed, right, dx. And now we're going to use integration by parts. And integration by parts is going to tell us, well, okay, so let's let u be the bad part, right? I'm going to make this part be u, and then the sine x dx will be the dv. So u is sine x quantity cubed. dv is sine x dx. Again, it's one reason I'm stripping off just a single sine x. Well, okay, there's a lot of options for what you could do with integration by parts, right? So why am I taking off this? Why am I stripping off this one sine of x? If I didn't strip off any, if I just tried to do integration by parts with this, you would introduce an x because you'd have to make this the dv, and so v would be x, but then you'd have x times stuff. So you'd be introducing actually something more complicated by mixing power functions with trig functions. That's not a good idea. If you broke it up as sine squared times sine squared, well, you need to know you have to integrate one of them and differentiate the other, right? One needs to be the dv, and that's already hard to integrate. So we want to split it up in such a way that we get something easy to integrate and the other thing we can always differentiate. So this is easy to integrate, this sine x right there. Okay, so the du, well, this is the chain rule. So this is 3 sine x squared times the derivative, which is cosine x, right? And then the v is the antiderivative of sine, which is minus cosine. Okay, so this is going to look kind of bad, but let's just try it and see where we get. So uv is going to be, let's see, we do u times v, right? So because this is now the integral of u dv, and so we're going to do uv minus integral of v du. So uv, there's a minus sign in there. There's a sine x cubed times a cosine x minus the integral of v du. There's another minus, so we'll pick up a plus. Oh, and this looks kind of terrible. 3 sine x squared times cosine x times cosine x. So it's actually cosine x squared dx. Okay, so maybe that's progress. Maybe that's not. Rather, the minus here became a plus because of that minus in the VDU. Maybe this is progress. Maybe this is not progress. But I'm actually gonna end up deriving this formula with n equals 4, right? And so here's the thing you can do. So again, it's not obvious, but we talked about how you can replace sine squareds with 1 minus cosine squared and cosine squareds with 1 minus sine squared. So I'm actually going to turn this cosine squared into 1 minus sine squared. So this I'm going to replace with 1 minus sine of x squared. Sometimes I write sine squared of x. Sometimes I just like to point out that it really means sine of x quantity squared. Because if we do that, then what happens? You'd think it make things worse, but we do want everything in terms of just sines, right? In this formula up here, we want something just involving sines. And so what are we going to get? Well, okay, let me just write it out. So we're going to get, let me just write out what the inside becomes. So the inside, then, this whole thing becomes, maybe I'll start writing the 2's there, sine squared x times 1 minus sine squared x. But, you know, it's a thing where we can distribute these terms, you know, distribute the multiplication. And so that's going to equal 3 sine squared x minus 3 sine squared times sine squared, which is sine to the 4th of x. Okay, so that doesn't look that great, but let's just go with it. Just go with it for a minute. So we've got this integral. I'm going to call this I again. It's going to be useful to call this I. So we've showed that I is negative sine cubed x times cosine x plus the integral of 3 sine squared x minus 3 sine to the 4th of x dx. But I'm gonna pull out 3's and break up this integral into, I'm gonna break it up over the minus sign and pull these 3's out. So we're gonna get I equals, just gonna write it all out again. Doesn't hurt anybody to write more. This is the same, plus 3 times the integral of sine squared x dx minus 3 times the integral of sine to the 4th x dx. But this is exciting. This is where I said it's like that weird e to the x sine x example, where this right here equals I again. This is the integral we started with. So we get that I, the integral we want, is minus, keep writing, cosine x plus 3 times this integral sine squared. I think you will see we're getting towards that formula in this specific case, minus 3i. So then we add the 3i over to the other side, right? We add it to both sides. Plus 3i over here on the left also, and we end up with 4i equals this. I'm going to be a little lazy and just say, well, we get a 4i, and then we're going to divide by 4 on both sides. So at the end of the day, we're going to get I, which is the integral of sine to the 4th of x, is equal to, so we're going to have minus a quarter, because we divided by that 4, sine cubed x times cosine x plus 3/4. I'm sorry, minus. Oh no, plus. Oh geez, okay. Gotta be careful. Plus 3/4 integral. Oh yeah, I moved. Okay, I moved this over, so this is no longer on the right side. I moved it over here, right? So it's really just this term. So plus 3/4 times the integral of sine squared x dx. Okay, and that is what we call progress, because we still don't know the integral of sine squared, but that's better than sine to the 4th. And we could keep going, but let me just compare this to the formula up here. In fact, maybe I can I copy this? Copy, paste. Yeah, let's see what these look like next to each other with n equals 4. Does that work? If this is a 4, this is a negative 1/4. That's good. Sine cubed, that's n minus 1, times cosine. By the way, it's kind of hard to parse this. The way this looks is kind of terrible. It looks like there's an x cosine x. Back up here too, I should have done this. This looks terrible, this x cosine x. That's why it's really a good idea to start to think. This really means, because you have to have sine of something, right? That's what that really means right there. Sine to the n-1 power of x, sine of x raised to the n-1 power times cosine of x. So that's what's going on here. That's why I wrote the parentheses to try to make it more clear. Plus, okay, so back to this checking. So this matches. And then look, n-1 over n. N is 4. I should probably make note of that. And then n-2 is 2. So this really is, we did really check the formula in this case. And so if we want the final answer, we have to do the same thing for sine squared. Maybe, well, we really should do it the long way. But if we wanted to try it for n equals 2 and just use this reduction formula, this would tell us that the integral of sine squared x dx is -1/2. Sine n-1 is 1, so it's a sine x times cosine x. Plus n-1 over n, but n-1 is n is 2, n-1 is 1, so that's +1/2. Integral sine to the 0 power. When we say that, what mathematicians do is they tend to just, something to the 0 power is 1. So that's really just a dx right here. And so this guy just becomes x. This term right here just becomes x. Okay. So if I plugged this all back in now, I do want a final answer. I mean, I wanted to illustrate this reduction formula, but I also would like a final answer, because why not? So I'm going to plug in right here. I want to plug all this stuff in right there, right? So if we do that, let me see if I can do that carefully. So we get then the integral of sine x to the, how did I change colors? Sine x to the 4th dx is, so we need this first term up here. I'm just going to copy that, -1/4 sine cubed x times cosine x plus 3/4, and then I got to copy this whole thing in right where that was. So 3/4 times -1/2 sine x cosine x plus 1/2 x. And then there should be a plus c at the end, right? Right, I said this integral, right? This integral of dx is really just an x. So that's why I put the x right there. Okay, and so let me just write a final answer. -1/4 sine cubed x cosine x. Oh, let's see, that's probably going to be a minus sign because we have 3/4 times -1/2. So that's -3/8 minus 3/8 sine x cosine x. And then we also multiply the 3/4 times this term, and we get another 3/8, but now x plus 3/8 x plus c. Wow. How do you feel? Very exciting stuff. Anyways, I hope that you're starting to at least get the sense that we could integrate sort of powers of sines and cosines that were, that's a thing one can do. You should sort of convince yourself once in your life that you can do these by hand, and then at a certain point, if it ever comes up in the real world, you would ask a computer to do it for you. But okay, at least hey, it's a feeling of accomplishment. We did it ourselves. All righty then. I think I can stop.